Alright, I got pretty much this left side here all squared away, and we're going to duplicate that on the right side, and I'll show you how I did that. Now, the one thing I did that I didn't videotape or anything is I put the belts on and figured out how much stretch I wanted on it, marked and drilled this for a rod, and took the two pulleys here, which are for clothesline pulleys, just took the bracket off. I drilled those to fit over the shaft and popped those in place. Now on the back side here, this right here is a casement window hand crank, just clamped to the shaft. Now on this side here, on the front, these do spin. Nothing on the drive or anything here is tightened down. I haven't set the pulleys yet. So they kind of spin on the shaft a little bit, but you can see that everything does spin the way it should. Once I get these actually tightened in place and get these two discs set where I want, they'll be a lot better. But I can't set these all up yet until I get the combs in place. I have two locking collars to smush these two plates together. And these I'm going to just drill and set screw right to the shaft, that way I can move them around. Now this here, let me get you a bit of a close-up, or closer. You can see, here's my battery cable. I just soldered these guys on, attached that to the screw there, and that's attached right to this little ball here. Now I thought these were brass, but they're actually not brass all the way through. They're just brass coated. So I did scratch one of them up. You can see the plating wore off there, but there's another quarter 20 screw sticking up that this is screwed to, which my battery cable attaches to. And on the inside here that you can't see, there's a wire going down the inside and touching that inside plate of the Leyden jar. And this right here is a piece of brass with a ball soldered on, and this is going to be my discharge rod. Now this is a very close hole. It's reamed to 1/8 inch, and this is an 1/8 inch rod, so we can still slide it in and out, but we're still making good contact around. I don't think I'll need to put a set screw in there, and that'll be able to adjust my spark gap by sliding this in and out. So basically we're going to duplicate it over on the other side, and what we have here is just 1¼ inch PVC cap. Now, for whatever reason, the ones that I have are pretty rounded on the end. A lot of times they're kind of square and flat. So I just had to sand a little flat on it. I drilled a hole to accept a screw and screwed that right to the base. The top, I drilled a clearance hole for a quarter 20 screw, which will, my fingers don't fit right up through the top. Now, coming off of the bottom of this is just some 16 gauge stranded wire that I stripped the casing off of, and all we need to do really is just wrap that wire around the screw here and make a nice contact. Get that through the hole and screw our top on just temporarily to hold everything in place here. And you can see we're wrapped around there and we're pretty tight. Actually, let me redo that. Should always, whenever you put wire around a screw, you want to make sure your loop is clockwise, not counterclockwise like I just accidentally had it. The reason for that is when you tighten it, it'll grab the wire and suck it tighter on the screw. If you have it the other way, stranded, especially stranded wire, when you tighten it, it'll kick strands off. Okay, that's a little bit better. And this we'll just tuck up to the side and let it hang through. Now we'll put it into our jar here, and all we need to do is take this wire here, and all I did was take a piece of tape, stick it down there on top of the wire, and just make sure it's making contact all the way through. It doesn't need to be crazy, you know, as you don't need to physically, you know, like mechanically bond it to it. The regular Scotch tape will do. And that's the basics here of our jar. And off the top here is going to be our discharge rod. So right now, let me go and I'll show you how I kind of drilled that hole. It's kind of a little bit of a rig that I got going on, but it worked pretty good. I'm going to go over to the drill press, we'll drill that hole, and we'll solder some cable. Okay, this is a setup I got to drill the hole now. It's not the greatest in the world, but it works for what we're doing. I don't have any decent V-blocks, small V-blocks. If you have something like that, obviously that would be the best way to do it. Just grab that by the edge, hold a V-block in there. But these are soft jaws for any vise, and it has basically a slot in the middle to allow you to hold round objects. So that's wedged in there by that little edge, and I have it overhanging the edge of my drill press vise. I have it marked eyeball center and punched, and I have a block underneath to hold it when we push down, because we're going to be putting a decent amount of force on it. So okay, we're through, and take I'm going to ream that hole out to size. And get all the nasties out of the middle. There it is. We're off a little bit, but like I said, that doesn't really matter. We'll just ream out the edges and we're good to go. Alright, and now I'm just gonna connect the battery cable to the terminals. This is what's in there now. These are solder on terminals, so obviously we have to solder them on. I would normally be using this little micro torch, but it's out of butane and I can't seem to find my little butane refill. I thought I had one lying around, but I may have used my last refill, or the last drop I had left. So anyway, I'm going to be using a little propane torch. It's way bigger than I need, but it'll still work fine. And the way I like to do these is I like to use some, it's basically a larger version of the electronic solder, and it's the same thing. It has a flux core to it, a rosin core. It's just thicker, and what I like to do is fill up the fitting about halfway and make sure I have a layer of solder all the way around, covering the entire inside, and then as I'm holding the heat here and it's still melted, plug the wire in and it'll instantly grab and it'll bond right to everything. So light this torch up. Alright, I don't know if you can see in there very well, but we got a nice puddle in there, and the flux is floating on the top. So we'll just heat it up till it's melted. Plunge our wire right into it. And there we go. Nice and on there, and that'll also, it's cool enough to touch already. You can also tin this. This is a tight fitting wire. In other words, the wire is the exact same size as the this connector here. If you have one that's a little oversized, what you do is you tin the wire first and then put it in, and that'll help it grab. But we're on there with that. So let me measure out how much we're going to need. I'll cut it and we'll do the other side. Okay, here's the other side. And there's the other side. And the good thing too is it melts the first little edge of the insulation when you put it in, and it kind of folds it over and seals up those wires nice. It works great if you use these on your car to replace an old ground on your battery cable. Keeps everything all nice and sealed up when it melts over like that. Especially around here in New England where you get salt and everything all over the place. So now, gotta get my brass balls. I'm gonna take my balls out of the package first. And just make sure these, I have two different size of these little balls. Let me make sure I got them both the same. Okay, I got that little ball in place. I tinned the tip of the brass rod. And what we're going to do is just set this in place. Heat her up. And let that solder flow right in, and then straighten out the rod. Give it a little twist, make sure there's no air bubbles in there. Just let it dry, cool down. You can aid it a little bit with some water. And there you go. Whenever you solder anything, whether you're doing plumbing or just playing around like this, whenever you're done, always wipe. If you're using soft solder that has any sort of flux with it, always wipe the joint clean. Otherwise, after time, especially on copper, you'll get green corrosion. And there you go. Nice soldered on there without any drips. So now we got to make the brushes for the discs themselves. Now let me put the machine back up here. I'll kind of show you how we're going to go about that. We got everything together there. Here's our little gap. We can adjust it by either swinging those rods in or out, or pushing and pulling them. And the only other two construction steps we got to do really before we start doing an alignment, or three rather, is we'll have to make the two brushes that go on here, which is basically going to be a kind of like a horseshoe here, and riding along this so we can turn it. And we also need a bar going across to touch both of these Leyden jars on the outside to link them together. That is just going to be a metal rod with two balls here touching the outside, and we'll be able to, or I'm going to probably put a post right here with it going through it. Now this, on the outside of this here, what I'm going to do is this is some oak dowel. I'm going to drill a 5/16 hole in here, and I'm going to push it on and drill a cross hole to take another one of these brass rods. That brass rod will be bent on both sides, and attached to the ends will be brushes just made out of stranded wire, and those are wired along the disc on both sides, and there'll be one in this direction here and then one in the opposite direction on the opposite side. And so let's get working on that. So let me cut some of this dowel down to length and drill the two holes in it, and then solder some wire to this. Okay, these are going to be those brushes. This is just a wood dowel drilled to 5/16. I have a screw pressed in there to anchor it, and I have an 1/8 inch hole with an 1/8 inch rod through it, and that's on center. So basically this is going to fit right over like that, and that'll give us adjustment once I bend it. Now I've already measured and planned it out. I'm going to go 5 inches from the edge here will get me where I want to be on these plates. Now it's pretty much arbitrary, as long as it's touching the plates. Now to bend it, I actually have this little bender. I've had this thing forever. I love it. I used to use it a lot for model making and bending railings and stuff for ships and different things. I'm pretty sure I got it at one of the hobby shops around town, and this thing's going to work perfectly for what I'm going to do with it. So I want these rods here to bend in, and I know it's not really going to show up on camera here, but I have a mark right at 5 inches. So if I slide my little bender on here and align that 5-inch mark with the end of this wheel in here, I don't know if I can zoom in and you can kind of maybe see it, I don't know. Not really, huh? But anyway, the mark is right at the edge of that wheel. Put her in there, get her nice and tight and lined up to where I want it, which is right there. Hold it and push. Perfect 90-degree bend. And let's see if we're where we want it. Yep, right where we want it. Move this a little bit. And we're right at 5 inches there. Now hit the other side. I'm just off a hair on that one, but it doesn't really make much of a difference. I'm off by about 1/4 of an inch, and just move it around. Just as long as this is centered, it doesn't make much of a difference. And then on the ends here, we're going to have our brushes. So let me bend the other one too. Alright, we have everything all bent and where we need it. Now, I cut the rods to length, and what I'm going to do is I'm going to solder on these alligator clips. The reason for that is, coming off of these alligator clips is going to be a wire brush that's going to be touching those the metal pads. So if I ever wanted to change the brushes or anything, all I have to do is unclip, pull it out. This is also the way they show on the plans too, which is a very good way, which is why I'm keeping it with that. Now, I'm not going to use the torch to do this. I'm going to use my soldering irons. I have a lot more control over this to go into there. Now, not that that's what this channel is about, but if you're ever getting into doing any kind of electronics or anything, spend the extra money and get a halfway decent soldering station. This is a, what the hell name is this? A Lenco. And get one with a adjustable temperature. Now this isn't a top of the line one, and this isn't my really good one. This is kind of my general purpose one that I use. I have a really good Weller soldering station. It's just a lot bulkier, which is why I didn't pull it out. And I like that one a lot because I have a ton of replacement tips of different shapes and sizes. And I used to use it a lot when I did a lot of electronics work and stuff with repairing video game consoles and modifying old consoles to be able to take S-video and component video to be able to hook up to current TVs rather than trying to use those stupid RF adapters. But anyway, so we're going to use that, and I'm going to solder these right into place. Now the trick is just you got to get the contact point hot enough. And the reason why I'm using the soldering iron, like I said, is to be able to, it's a lot more controllable. I'll be able to pinpoint the heat. Now this is brass against this this other metal, which I'm assuming is some sort of aluminum or maybe just nickel plated brass. But if you scorch the nickel on this, you're pretty much screwed. It's never gonna stay on. So you can see right through that little spot right here is right where I'm gonna drip the solder. Now I don't need a whole lot in there. Tighten down the vise here. I just need enough for it to stay. And there we go. Now these are going to be, like I said, wire is going to be held in these. I'm just going to use the same stranded wire that I used to put inside the lighting jars. It'll just be clamped and spread across the discs. Now I'm going to make one more bar, and I'm going to solder in 2 balls on the end, and that's going to be to link the lighting jars together, and I'll show you that when we get everything back up on the table. Okay, time for assembly. First thing I'm going to do is I'm going to get the discs in place. So I want the shaft. I have a locking collar here. This will allow me to keep the disc together. Then one of the discs. Then a small spacer and washer to keep those holes from grinding against each other. And the other one. And then, oops. Actually, I did the same thing I did with my lathe. Got to put the belt on first. There we go. Now the other belt. At least I didn't forget both of them. And that into there. Okay. So we'll figure all that out, spacing, once we get the rest of this in. So now, pan you down to here. You get one of those little set screws I have floating around here. These things are tiny as all hell. Which is why I got 6 of them, because I knew 4 of them were going to go flying across the room at some point. Trying to put them in this hole. Okay, now they're angled out. Obviously I want them angled opposite of each other so I can get the screwdriver in there. The shaft in, put the belt around the shaft. Remember that one. One pulley. Now these pulleys are pretty snug, so I am going to have to force them on to a point. And then the other pulley here. Push that shaft all the way through. Now, what I'm gonna do right now, just push these pulleys away from each other. Now I'm kind of just eyeballing center on this. And grab a Allen wrench. Okay, got that collar locked down. Now I'm just putting pressure on this to hold the two discs together, but I don't want them to bind. I still need them to spin relatively freely. And that's just a little too tight, so I'll loosen it up. That's pretty good there. Okay. So now let's get our collectors in place. Figure out exactly how much we have to trim off of them. Okay, I'm gonna go trim these off. I gotta trim about 1/8 of an inch, so I'm gonna take it from both sides, and then we'll get back to putting them in. Alrighty, I cleaned up my disaster of a workbench a little bit, and she's all together. I saved you the boring part of just putting together. Let me go handheld here, and I'll show you kind of what we got going on with this. I have tested out, and it works. And let me tell you, those Leyden jars pack a punch. It's my stupidity. As you can see, I got little rubber knobs on here. I had these really long, and I was standing right next to it as I was cranking it. Instead of arcing through the little balls, it arced through my shoulder. And let me tell you, that hurts. And so here we got our little brushes here. You can see the other one behind it at the opposite angle of this. We're roughly halfway between the collector combs. The combs themselves here are adjusted as close as I can get to this without them you know, rubbing up against here. And I got a little bit, there's a little bit of play in this disc itself. It's got a little bit of run out, and that disc that I had in the middle, I actually had to take out. It was a little too wide. It was making this wobble like crazy and not making the machine work. So when I do turn it, you're going to hear a clank, clank, clank. That's the screws rubbing up against each other inside here. I'm thinking I want to take this apart eventually and stain the oak. So what I might do when I take it apart is, instead of using screws in there, is I'll take and I'll put plastic pegs straight through and just bond them to the plate. Our discharge rods here, which are adjustable, and it's a little bent, huh? Oh well. Our Leyden jars, which you saw me make. Now this here is to link the jars together. Like I said, I have a few adjustments here and there to make. These weren't staying directly to this outside foil. It has to be bent at an angle. I just haven't done that yet. And same thing with these here. These collector combs were bending out, so I just have them taped in place. I'll end up putting a screw in place here, or I'll glue those in place at some point. And here is our cable into our Leyden jars, which will allow us to switch these out to bigger ones, smaller ones, whatever we want to do. Those two pulleys here, as you see, one belt is crossed to allow this plate to rotate at a different direction. And we have the pulleys that I made, and everything's smushed together with some lock collars, one on either side here. This is just a piece of oak dowel that is drilled and pressed onto the end here. I actually tapped the wood, and I held a set screw just to hold the collector rod, so I'll be able to adjust the angle of that. And that's pretty much the gist of this thing. So let's make some sparks. Okay, you ready? Make some sparks here. Cool thing about this is, as you spin it, you can actually smell the ozone created. And see how big of a gap you can get. Always short them out before you touch them. And it's getting a little hard to turn. Looks like it makes a pretty big gap. Pretty big sound too. Shut the lights off. Okay. See how this shows up here. See if we can get that a little bit bigger. That right there is about a 3-inch gap, so see if you can pop that. Nope, that's its limit. I don't know if you can see right up here where these brushes are, or down here where these brushes are. Let me see if we can zoom in on it. You'll actually start to see it spark there. So I know that's about an 1.5 inch gap. Turn the lights back on. So that's pretty much it. That's Wimshurst. That's what it does. Pretty cool machine. I do want to show you one thing. Let me get this out of here. What inspired to build this now, this guy is a little worse for wear. I built this with my father in 7th grade, I believe, and it was hand cranked. We had another pulley here with a belt on it. This belt here is actually made out of silk. It's a Van de Graaff generator, if anybody doesn't know, and this is kind of one of the first things that I remember really sitting down with him and making. I mean, I helped him. He worked on his trucks, his canteen trucks and stuff that he owned, and I always, helped him with that stuff. But this was one of the first things I remember sitting down and making specifically for me. I mean, I helped him with his projects, but this was one of the first things that we made, that I wanted to make, that he helped me make. And actually this globe here is 2 dog bowls braced together. And this didn't work. We couldn't get it to work. No matter what we did, we couldn't get it to work. And we actually called the Museum of Science in Boston, and because they have basically a giant one of these. And we brought it down to one of the guys that actually runs that, and he took a look at it and gave us the pointers of what to do. And I tried it out. It actually still works, but it was one of the first things that we made, and kind of why I saw the Wimshurst, and it kind of made me remember this, and I wanted to build it. So, but that's it. That was the Wimshurst generator, and I'm gonna end up taking it apart, staining it, and getting all the little kinks worked out of it. But she definitely works. Might try some different Leyden jars and see if I can get a bigger spark out of it, but that's the basics of the Wimshurst. I'm pretty impressed with it, actually. I do like it. So, hope you guys enjoyed this series of videos, and hopefully I can get to another one pretty soon. And I also, hopefully, if I can swing it, do have a little bit of a surprise coming. I do have a little bit of a, if I can get my hands on it, a little modification for the lathe, which hopefully works out. I'll find out Tuesday, actually. So that's it. You guys have a good weekend, good Memorial Day, and I'll see you on the next video.